Okay. Good afternoon, all. I hope everyone is doing well. I am Nebiyou. I am a clinical data and regulatory coordinator at CanDIG. My work involves understanding clinical research data sets and mapping the representations into different data models, two of which we'll be discussing today. I work closely with developers and also with data custodians in order to do this data mapping, the validation. My background is, I have a clinical background, specifically in patient care and communicable disease surveillance. So today I'll be talking about mCODE, which is the minimal common oncology data model. Okay, so this is a sample treatment plan for cancer, and this is how data is usually captured at point of care in hospitals and specialty clinics. So Form A is recommended by the American Society of Clinical Oncologists, and Form B, as you can see, is used by the Gwinnett Medical Center in Georgia. I'd like to bring your attention to some of the data elements being collected here for same type of data cancer, the same type of cancer. Now, when we look at the middle section, we see that both have the same header for this section, which is background information. So we expect a similar data to be collected. However, Form B requires symptoms and signs to be collected here, but Form A does not. And probably the same data is recorded under another section in Form A. Again, in the same section, we can take a look at Form A, and there's a request for echocardiogram, which is absent from B. So this simple example shows that even from a simple section, such as this one with a treatment plan, there are data discrepancies. The data is collected in different formats, and this kind of incompatibility is one of the major issues to sharing cancer and research data. So mCODE is short for Minimal Common Oncology Data Elements, and is a data model intended to assemble a core set of structured data elements for oncology, for oncology. mCODE specification is organized by 6 high-level domains, as seen here in color coding. These are the patient, laboratory and vital, disease, genomics, treatment, and outcome. In total, around 23 mCODE profiles are composed of 96 data elements, and each domain is organized into several concepts, which then have associated data elements. For example, on the right, when you see the treatment domain, which is in yellow, it includes profiles for cancer-related medication statements and cancer-related procedure statements. This is for surgery and radiation, and cancer-related medication contains data elements of treatment intent. It can be curative or palliative, and medication start date and end date, and reason of termination. So there could be different methods of cancer staging, such as the commonly referred one, which is staging from 1 to 4, but mCODE utilizes the TNM staging method, as seen here in brown on the top left corner. T stands for tumor and indicates the size of the tumor and whether it has spread to other parts of the body. And N stands for nodes or lymph nodes, and it describes whether the cancer has spread to adjacent lymph nodes. And M is for metastasis, which indicates whether the cancer has spread to other parts of the body through the blood or lymphatic system. And also in blue, the right bottom corner, we see the laboratory tests that include tumor marker tests, which have test code and test result elements. In addition, we see complete blood count and comprehensive metabolic panel as depicted by CBC and CMP respectively. So mCODE provides a common standard and language to collect to collect oncology data. Collecting cancer trial data using such kind of common model helps to ensure that we are able to share data and perform large-scale analysis across distributed systems and research institutions. However, only about 3% of cancer patients in the US participate in clinical trials, as reported by American Society of Clinical Oncology in 2019. And at the others, 97% of the data is located in electronic health records in different institutions, which have systems that are incompatible with one another. So the immediate relevance for CanDIG is that the Marathon of Hope Cancer Care Network, which we support, has mCODE as part of the minimal data set requirements for their new cohorts. So the Marathon of Hope Cancer Care Network is the largest of its kind in Canada and aims to create a high quality and shareable data sets of 15,000 cases in the next 5 years and up to 100,000 cases within the decade. This data will be collected using mCODE, and as such, CanDIG needs to support mCODE as a common data model. The previously collected data not captured using mCODE will also have significant insights into cancer research, and it falls on us to do the work, the mapping work to mCODE. So this is the mCODE data dictionary that defines what each data element in the data model is to represent. It also indicates must support and required if known elements. You can, as we can see here, it has the profile section and also the groupings and finally the data elements. And each data element, it has a description. And this is important in order to do any mapping between two different data models. So this is a sample clinical data prepared for demonstration of this presentation. And it's a similar representation of the actual data that's captured as diagnosis and contains specific values that are entered during the initial identification of cancer. So most of the data comes in the form of Excel or Google Sheets and sometimes case report forms. You can see that the column headers are assigned a variable name, which differ for each project. Figuring out the meaning of these variable names is an important task of the mapping work. Variable names are stored in data dictionary of the data file. However, there are occasions where it might not be provided. So if there is a confusion with the meaning, a discussion with a data custodian is warranted. So the first step of the mapping process is understanding the data, each variable, what it contains and what it doesn't, figuring it out as it relates to other data elements. This is where my clinical background kind of comes in handy to understand the meaning of these clinical terms. So I would like to take your attention to column I. Under column I, the stage corresponding to the particular type of cancer is recorded by Roman numerals using the common 1 to 4 staging. So the next step involves manually transferring data to mCODE according to the description in the data dictionary. This is a sample, again, the sample map data. At this stage, the aim is to map as much of the data to mCODE as possible. There will usually be some level of data loss. This can be either due to the data to be mapped does not include mCODE elements, or the data is there, but it does not correspond to the mCODE description as per the data dictionary, or it contains additional information that's not captured by the data model. So for example, in the previous slide, we saw that the data set contained cancer staging. However, if you see the rows 20 to 22 here in brown color, the mapping indicates NA, which means not available. This is because, as discussed in previous slide, mCODE uses the TNM staging system, while the dataset contains other staging systems not supported by mCODE. But cancer staging is an important information in cancer research. But however, in this particular diagnosis datasets will not have the staging data. This could be a significant data loss. Another example is where the demography section row 4, where sex from the dataset has been mapped to birth sex in mCODE. However, I put remark in the notes section to discuss with the data custodian because I cannot be sure if sex was recorded to mean birth sex. So therefore, even for what seems simple and logical as this demographic data, it requires detailed discussion with data custodians. So once the mapping is completed, the third step would be to discuss with the data custodians regarding the mapping and if they feel it is correctly represented. Here, the data custodian is the primary person to validate the meanings and terminologies used in the research project. Once the data custodians approve the mapping, the next step involves working with a developer to ingest the data to the server. Here, the person who completes the mapping, in this case, me, will finally validate the results. So finally, I would like to leave you with a very brief introduction to another data model, which is OMOP. OMOP will allow us to extend mCODE by supporting more comprehensive data. For example, one of the data sets that I've been working on, the INSPIRE data that we recently completed the mapping to mCODE, it has additional data on things such as laboratory tests, such as urinalysis, thyroid function, coagulation tests, and data on sites of metastasis. These things cannot be mapped to mCODE, so we will extend it to OMOP and we'll cover it. As such, for CanDIG V2, we'll also be incorporating OMOP as part of our data model. We will continue using mCODE for Marathon of Hope cancer care network projects, and mapping will be completed between mCODE and OMOP to facilitate representation between the two data models. So this is all I had. Thank you so much for your time listening.
That was great. Thank you very much, Nebiyou. Looks like we did get one question through the chat from Daisy. So they asked, are the other staging descriptions corresponding to the TMN system? Are there competing standards that have known mappings?
Sorry, can you repeat the question, please?
Yeah, of course.
Sorry, I didn't ask the question very well.
Oh, hi.
Or Daisy can ask. Perfect.
Yeah, I was just wondering about like, are these like so mCODE is like a minimum set, right?
Yes.
So like, do these other standards, like, do they like, are other descriptions that other institutions use that aren't compatible with mCODE, or at least don't overlap entirely? Is it that they can't map, or like or is it are they standardized in some other way, like they're according to some other standard that can be known to map to mCODE's stuff in some way?
Yeah, so I mean, there are different types of cancer staging. So depending on which type you use, you enter the data depending on the type of cancer, staging you use. So for example, mCODE only uses the TNA model. So in order to map the stagings to mCODE, the data that should have been collected or should be collected with TNA model, TNM staging types. So for example, as we saw one example in one of the slides, the data included staging data, but the staging was done with the normal, like stage 1, 2, 3, 4 stages.
Those can't be mapped because they're like qualitatively different than the
qualitatively
TNM model.
different. It becomes qualitatively different. That's one of the things, like either we have to collect the data, go back and collect the data according to TNA model, or else it cannot be mapped for this. But the marathon.
Was there a reason that mCODE didn't pick that up? Because like the other staging models?
Yeah, so mCODE generally represents the minimum data set that can be collected with oncology, so that it can inform decisions based on like analysis. And so they only selected like one cancer staging method, which is the TNA method. So that's just because it's a minimum data set. So they chose that, okay, the best way to support this data model would be to use the TNM model.
Okay, so it basically, so we would have to extend our model with mCODE plus some extra things if we wanted to incorporate other standards.
Yes,
Can we?
definitely. That's why mCODE. That's why we are also including OMOP as another data model, so that we can extend those things that don't map to
Okay.
mCODE.
Thank you.
Okay, thank you.